All right, we're asked to prove this identity here for sine hyperbolic x, or sin x. So the definition is that it is e to the x minus e to the minus x over 2. So we've pretty much got this bit sorted. And we've also got this bit sorted because we're just going to replace x by 3x in that one. So it's all about getting the cube of sin x. Well, for this, I'm just gonna cube this expression. So straight away, I'm going to get 1 over 8 by cubing the 1 over 2. And I've got e to the x minus e to the minus x cubed. Now you can either expand the bracket like triple brackets here, or we could go for a binomial expansion, and that's going to be a little bit quicker. And then either use 3c0, 3c1, etc., or Pascal's triangle. There we go. These are our coefficients. So I'm going to get 1 over 8, then e to the x cubed plus 3 e to the x squared times minus e to the minus x plus 3 e to the x times minus e to the minus x squared plus e minus e to the minus x cubed. This is going to become e to the 3x. Over here, I'm going to get e to the 2x times e to the minus x. That's back to e to the x. Then it's going to become a minus. So minus 3 e to the x. Then plus 3 e to the minus x when I deal with this one. And then minus e to the minus 3x. So therefore, 4 sine hyperbolic cubed x plus 3 sine hyperbolic x is going to be identical to a half e to the 3x minus 3 e to the x plus 3 e to the minus x minus e to the minus 3x. Okay, we'll expand the bracket in a second. Plus 3 over 2 e to the x minus e to the minus x. And I want to show that we get then this here. So let's expand the bracket. We're going to get a half e to the 3x minus 3 over 2 e to the x plus 3 over 2 e to the minus x minus a half e to the minus 3x plus 3 over 2 e to the x minus 3 over 2 e to the minus x. And these cancel. So I'm left with e to the 3x minus e to the minus 3x over 2, and this is sine hyperbolic of 3x. Nice. Hence solve this equation. Sine hyperbolic 3x equals 19 sine hyperbolic x. So what we can do is replace the left-hand side by this. So 4 sine hyperbolic cubed x plus 3 sine hyperbolic x is going to equal 19 sine hyperbolic x. All right, and I'm going to minus 19, so then I'll get 4 sine hyperbolic cubed x minus 16 sine hyperbolic x equals 0. Factorize out 4 lots of sin x. So either sine hyperbolic x is 0 or sine hyperbolic squared x is equal to 4, which means sine hyperbolic x would equal plus or minus 2. Now we've just got to solve these to get our answer for x in terms of natural logarithms where appropriate. So we are given the inverse of sine hyperbolic. I will show you where that comes from at the end of this question, but we can quote it here. So now that's what I'm going to be doing. I'm going to be doing x equals our sine hyperbolic 0, for example, and then the same with 2 and minus 2. So if I deal with this one, I'll do it here. I've got space for it. It's going to be ln. You might even know the value of this one. In your calculator, will be able to deal with it. We just get 0. But yeah, we get ln of 0 plus 1, which is just 0. Or we're going to get ln 2 plus root 5, and I substitute 2 in. Or if I substitute minus 2 in, I'll get ln minus 2 plus root 5. Those are our three answers. Nicely done. Let's just finish by actually deriving this. So it does start from the definition of sin x, e to the x plus e to the minus x over 2. And I'm going to call that y. And then to find the inverse, we make x the subject. So we'll get e to the x plus e to the minus x equal to 2y. And then I'm going to times through by e to the x. So e to the 2x minus 2y e to the x plus 1 is equal to 0. And I've constructed a hidden quadratic in terms of e to the x. This e to the x is actually e to the x squared. So that means e to the x, I can just now use the quadratic formula. I mean, I could complete the square. Maybe I'll do it that way. So e to the x minus y squared minus y squared plus 1 is going to equal 0. So e to the x minus y squared equals 1, sorry, not 1, y squared minus 1. And then we can take the square root. E to the x minus y is going to be plus or minus the square root of y squared minus 1. Now remember, because we're dealing with a function, like there's only going to be it's going to be a one-to-one mapping. And it turns out you take the principal value and it's just going to be positive. I'm not going to go into details on that here. But e to the x is then going to be y plus the square root of y squared minus 1. And finally, we can take logs. X is going to be ln y plus the square root of y squared minus 1. And now we just swap it around. So our inverse function, which is this, is actually going to be ln x plus the square root of x squared minus 1. There we go. We've proven this result.